This video presents the digital twin architecture developed and installed in the Industry 4.0 laboratory of the School of Management of Politecnico di Milano, which just appeared in the top left corner of this video. The assembly line is equipped with a manufacturing execution system which is shown in the top right corner. The digital twin is installed in another machine which is shown in the bottom left corner. The architecture is also based on a smart controller which is shown next to the MES in a black terminal. The controller schedules and controls the assembly activities over the line. The controller also listens for the events occurring during production, such as the arrival of new orders or the completion of already released ones. While the MES communicates with the PLCs and the sensors on the line and stores the information on a Microsoft Access database, the controller uses the same database for interacting with the line. In order to improve its decision-making capabilities, the controller may communicate with the digital twin, which can simulate the behavior of the assembly line. The communication between the controller and the digital twin is realized through HTTP protocol, as the controllers and the digital twins exchange messages concerning the requests for simulation and results. In fact, the controller runs some services which require simulation capabilities, which include the prediction of bottlenecks on the line and simulation-based scheduling. Those services are usually executed as response to events or on a time basis. Connection with the digital twin is established by creating a new digital twin instance, as you can see from a new window of plant simulation being opened. This instance is then able to process the request received, and it's eventually closed when it's not necessary anymore. The only part of the architecture which is not shown in the video concerns the transfer of the information required to synchronize the state of the digital twin with the state of the line, which is realized through a dedicated cloud where the line equipment publish their own information and from which the digital twin is able to retrieve them by connecting to an Azure cloud service. The solution allows to run multiple services in parallel and allows the digital twin server to provide simulation to any request received. Moreover, being on a separate machine connected to the internet, the digital twin can be reached from anywhere. Also, since the digital twin is used by a controller which has to run multiple functions for controlling different aspects of the assembly line, each function of the controller is implemented as a separate server that can send different requests to the digital twin for receiving simulation results. Concerning hardware and software implementation, the line is made of Festo equipments and Siemens PLCs. The MES is also proprietary Festo software. The digital twin model was developed in Technomatics plant simulation by Siemens, and the cloud services are provided by Microsoft Azure. The digital twin is exposed through the NGRock platform, which allows to make the digital twin address available through the internet. The remainder of the architecture, which consists of the digital twin engine, which is responsible for managing the requests received by the digital twin, and the smart controller, which was described before, are implemented completely in Python programming language and are available on GitHub.